Alrighty, here we are, geometry class. We are doing rotations, which is section 9.3. And we have talked a lot about transformations and the different things types of transformations. And some transformation yield things that are bigger, smaller, or they simply move it around. And a rotation is a transformation rotating each point a certain degree measure. So this is something that's just going to rotate. So is a rotation an isometry? Well, yes. So considering if this was a figure right here, and I'm going to rotate it, let's say this many degrees, I still have the same figure, right? It's a congruent figure. It didn't change. So is it an isometry, which means again that you still have congruent figures? The answer would be, of course, yes, it is. So what is the image of LOB for a 100-degree rotation about C? So first thing we need to do is talk about counterclockwise and clockwise. So I want you to take note down here, and I would like you to actually copy that. So I'm going to ask you to pause the video, or somebody to pause the video, so that you can copy that. Because when you see a positive sign, that is counterclockwise. When you have a negative in front of the degree measure, it's a clockwise. So, and there's also a way to look at the coordinates. So if you have these coordinates, an x, y, and you rotate 90 degrees clockwise, your coordinate, new coordinate, like if this was 1, 2, now it becomes 2, negative 1. Okay, 90 degrees counterclockwise, if it was 1, 2, now it becomes negative 2, 1. And 180 degrees, it doesn't matter, obviously, if you go clockwise or counterclockwise, you're going to have the same thing. So it becomes, an xy becomes a negative x and a negative y. So 1, 2 would become negative 1, negative 2. 270 degrees clockwise, which is highlighted pink because these two are the same, right? If you go 90 degrees counterclockwise, like a fourth of the way, it's going to be the same as if you go 270 degrees clockwise. So the result is exactly the same. Just like the 270 degrees counterclockwise is exactly the same as if you went 90. 90 degrees clockwise would be here. 270 degrees would be all the way back around up here. So those are the same. So you can copy those down. I do believe I give you those for the test. All right, so back to this now. You're going to need your protractor. So if you don't have your tools, pause the video, get your tools. We notice, oh, there's my guy. There's that little birdie there. All right, so it's a positive. So if we look at the bottom, positive was counterclockwise. So here's like the center of your clock. You can think of it like this, and here's our clock here. So if we're going to go a positive, and then because it's positive, it is counterclockwise. We want to get a good idea where we're heading so you know if you're doing it right. This is going to go this direction, 100 degrees. So what you need to do, and I'm going to use different colors, so that might be helpful too, but we need to be able to measure angles. So let me get out my protractor. Yours is going to be easier, I think, to use. Maybe not, because it's not so big. But what you want to do is always start with the center, the points, and pick your point. So we'll start with, I don't know, what do you want to start with? O? Let's start with O. We have 3 points, 1, 2, 3. So we need to move 3 points 100 degrees and then connect our new points. So this is, again, my, what is that, pre-image or image? Right, that's my pre-image. So I'm going to draw a line. And I'm going to go all the way through it because I need to be able to measure my angle, and especially me with this big protractor, I'm going to need long lines. Okay, because this is my center right here. So I now am going to line that up with the center dot. And I'm going to line up this line over here with this bottom line here. So let's line that up. And I need to go 100 degrees. So I'm following my 0, which is the inside set of numbers for this. And if you notice, we go 10. Oops, yeah, I'm going to shift this instead of shifting. So I'm going to go 10, 20, 30, all the way up to 100. And I'll put a little dash there. And that is what I'm going to also connect to the C. Okay, so far that is my first 100 degree right here. I went on 100 degrees. Question is, where does the dot hit? So I also need, I hope I have it in here. Oh, I'll just be crushed. I will be absolutely crushed if I don't have my compass. I might cry. I really might cry. Oh my goodness. This is devastating. Oh my goodness. This is terrible. All right, I have to pause the video and go look, and I'm not going to shut it off this time. I'm going to pause it. Have no fear. Mrs. Silva is here, and you know it. I had a beautiful compass here, all ready to go. So what we're going to do is measure the length from the center point to there. So you should be doing this with me, by the way. Don't watching never works. Never. Remember, hold your compass like a pencil. And what did I always tell you guys with these? Although it's not, this isn't as hard because you don't need to have like a lot of any circles, but what you want to do is then go up this way and mark your arc. Let me make sure I did that right. Yep, I did. Okay, so that, where that hits right here, what am I going to label that? Yes, I'm going to label it O prime. You got to label these things and do them one at a time. I'm going to grab a new color, and I'm going to take the next coordinate, or next point, I should say, which is L. So again, we start with center, and we go through L, and we extend it. I'm going to extend mine a little bit further to make sure it lines up. Okay, then again, I flip it because I want to go the right way. If I set my protractor up this way, I'm going to be going that direction. So I want to set my protractor up this way so that I can go this direction. Okay, so again, we're following the 10, 20, all the way up to 100. I'm going to make a little dash right there at my 100. Use my straight edge from the center. Oh dear, did I miss that line? Right through. So then again, here is 100 degrees there. Now again, how did I figure out exactly where on that coordinate? I use this. So I measure out from the center to L. And then I again put the center right here and make my little arc. Where that arc intersects is going to be what, class? L prime. Good. And my last color, I shall pick blue. So I'm hoping you're following the pattern here. So we're drawing a line. Feel free to stop this and pause it or rewind it as much as you need to. From the center, see they're all starting at the center through. Now I need to again, I don't want to set it up this way. If I set it up this way, then I'm going the wrong direction. I want to set it up so it's facing the direction I'm going. So I got to line up that bottom line as well. And then I'm going to go all the way around till I hit 100. Oops, I'm not in the camera. There we go. Then here's my point up there. So I'll draw a line through it. So So there's my third one. I'm going to go on the inside here, all the way over there, 100 degrees. So I'm doing 3 different 100-degree measures. Now that's not my point, nor was that, nor was that. Those were just to get those lines. I need to use my compass. Measure from C to B, and then go right here. Draw your arc. And it is B prime. Yay! O prime, L prime, B prime. I can now connect them. Voila! There you go. And that is my image. My pre-image rotated 100 degrees. Pretty cool, huh? All right. So we have another one on the bottom to practice. So if I were you, I would stop it. Try it yourself. I'd take a break. That was exhausting. Strawberry lemon burst stevia today. All right. So I would say pause it. I'm going to run through it now. I notice it's positive 50 degrees. So we know it's going to go clockwise about B. So this is slightly different, class, because the point isn't like up here. That was all. It wasn't on the figure. Down here, we're rotating around this point on the figure. We're going around this point. Well, there's good news and bad news. The good news is you don't have to rotate that point. So we're down to 2 points we have to rotate, whereas up on the top we had to rotate all 3 points. The bad news is it can be a little more complicated. It's not more complicated, it just looks a little different. So, but it's still the same concept. So you still start with the center. You see your point 0. You need to go through it. So it's going to go right over that line all the way through. And it's going to go this direction. So I'm going to set up my protractor like this, not like this. Otherwise, you're going to go this direction. So we set it up, line up the bottom. And it's 50 degrees this time. So I need to follow my 0 up to 50. Draw a line straight through. And use my compass to measure from B to O. And then from B to, what is it going to be called? O prime. Good. So we only have one more left. I will use a green. And we're going to go through now L. So again, I'm starting with the B, going through L. And I need to measure, oops, I didn't mark that. This was, from here to here was 50 degrees. I think it's just helpful so you see what line is going with what line. That's why I really recommend different colors. Otherwise, you just end up with all these pencil lines everywhere and you're like lose track of what's with what. So we did the L there. Now I need to line this up and measure my 50 degrees. So I'm lining up the middle here, lining up the bottom line. Oops, I'm going to slide this down. Go to 50, which is right here. I need to draw a line from the center, which in this case is B, and grab my compass, and I'm going to find how close it is to L, and now that is how close it'll be over here. What am I going to label that, class? L prime, you got it. Connect them, and mine looks a little lame, I will tell you, I can tell already. But here it is. You see why I'm calling it lame? Looks a little bit smaller, doesn't it? Of course, this looks like I drew it freehand, so I'm not quite sure why I did that in the first place. But This is my pre-image. That's what I started with, and this is my image. Okay, so there's another page for today. We are not done with that. We have a different piece, but that's it for the construction part. So, you know, make sure if you need help or you forget how to do it when it comes to review time, you can go back and look at that. So let's go to the second page. Let me get my camera back in order here, the way it was. Okay, so remember, if you have a regular polygon, what is that exactly? Yep, I know you guys knew it. It is all sides and all angles are congruent. Well, you know, you were working with figuring out angle measures, and we were using n minus 2 times 180 to get all the inside angle measures with those. Well, we're going to do something slightly different, and it's dealing with the center of it, because if you, the center of a regular polygon, if you put a dot right in the center of it, like let's just say we have this, and of course you know this won't be perfect, not even close, because I'm Mrs. Silva and I don't do drawings well. But the point right here, the center of that polygon, the truth is this is equidistant to all the vertices if it's irregular. So that's what's kind of cool. This, and this are all the same. So let's write that down. So point equidistant. I shouldn't say, what in the heck? Okay, hang on. I'm looking at points, wondering why I put a plural while I'm spelling equidistant wrong. From its vertices. Okay, so this point is equidistant from all of the vertices. Remember, these are the vertices. Those are the vertices. Okay, so we're going to walk through problem 2 on page 560 right now. 560, let's see here. Okay, so I'm going to plop this in here and see if I can get it on the camera. Okay, so they're talking about the center of a regular polygon, which is what we just were talking about. And let's read it together. So point X is the center of the regular pentagon, penta. Well, how original that is. What is the image of the given point or segment for the given rotation? So here's the deal. We can rotate like this E, and it can rotate around here. But when it tells us, oh, what is if we rotate T around X 72 degrees? Well, you can figure that out without using a protractor or anything, because you know that all the way around in the middle here is 360, right? Full circle. And if it's all equal, then we have 5 equal segments. So that's going to be 72 degrees for each of these little chunks. So when you take T and rotate it about X, a positive 72, that's counterclockwise. That's going to rotate this way, and my answer will be N. If it's 216 degrees, well, let's see how many chunks that is. So 216 divided by the 72 is 3. So we're going to move it 3 spots, and it's positive. What are we rotating? Rotation of Tn. So this whole segment about X. So Tn will go 3 chunks. So T will rotate 3 spots. So 1, 2, 3. So that's going to be P. And N will rotate 3 spots. 1, 2, 3. And that'll be A. And that's how they got PA. So you guys can tell me what is the image for E. So here's E for 144 degree rotation about X. So 144, how many chunks of 72 is that? Right, it's 2. It's positive, so we're going to go counterclockwise, and the answer would be A, point A. Good. Oh dear me, what am I dropping here? So just to have a few notes written down from what we just talked about. That's summing up what we were just doing. Now look at 561, got it, number 3. Let's take a look at that one. This camera is the best. I love it. All right, so hubcaps of a car wheel are often have interesting designs that involve rotation. What is the angle of rotation in degrees about C that Q maps to X? Okay, Q maps to X. So let's take a look at that. The design consists of 9 spokes. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9 spokes. So it divides the circle into 9 congruent parts. So if you take the 360 degrees and divide it by 9, each of those little chunks is 40. So we have a 40-degree rotation between each spoke. So moving counterclockwise, Q touches 6 spokes as it rotates to X. So right here, 1, 2, 3, 4, 5, and 6. So it rotates 6 of those chunks of 40. 6 times 40 is 240. Now, in problem 3, what's the angle of rotation about C that maps M to Q? Well, again, we want to see from M to Q. We're not taking the shortest route. It's a positive. So we're going to rotate counterclockwise. So 1, 2, 3, 4, 5, 6 spots again. So it's actually going to be exactly the same. 6 times the 40 is 240. So each angle is 40 degrees. So the 40 degrees times the 6 is 240 degrees. We go clockwise. I mean counterclockwise. Okay, our last one for this lesson. What are the coordinates of the image of point A, which is -2, 3, for a composition of 2 90-degree rotations about the origin? Okay, so do you remember what we talked about yesterday? What does a composition mean? It means more than one transformation. So if you are moving 2 90-degree rotations, what are you ultimately doing? Yes, you are moving at 180 degrees. So let's remind ourselves, we've got this little handy-dandy thing here. So XY then, if you're going 180 degrees, all that happens here is the X and the Y both become negative, or they flip sign. So I'm just going to copy that rule down right above it here so you can see what I'm doing. Negative X, negative Y. So that one becomes A prime, right? Our pre-image and our image, and it's the opposite of X. So that changes to a positive, whereas that one's going to change to a negative, and that would be your answer. All right, very good. We'll see you tomorrow.